Alright, here we go. This is paper 1, new style GCSE from November 2011, paper 1 non-calculator paper. As you can see, once again, I've created a running total here to see which questions kick in the GCSE grade. So we need to get to the end of question 4 with everything right before we start to qualify for GCSE grades. So, without further ado, question 1. Complete the following check by writing the amount in figures on the line provided. So what we have to do here is to take this written description of the number, £46,705 only. 46,700, no tens, and £5. Okay, and you check it, as I've shown you in previous ones, by working from right to left. 5, 5, 705, 6,705, 46,705. The second one, we have to go the other way. We have to take the digits and turn them into words. 7, 17, 417, 9,417. So the words would be 9,417. And then you can add the pounds only, but what they're looking for there is the digits, the numbers. B. Write the following numbers in order of size, starting with the smallest. Well, hopefully there we can see that the smallest one is 46, and if you put a little dot under to know that we've counted that one, then scanning the list, 64 would come next. Then we're into the hundreds, 406, 460, and then we have these two left, 604, and followed by 640. Write down the sum of 54 and 48. Sum means add, so we've got to do 54 plus 48. 8 and 4 is 12, 2 down, carry 1, 5 and 4 is 9, and 1 is 10, so that's 102. The number which must be added to 85 to make 113. So what we do there is, if we do the subtraction, 113 take away 85, the difference is what you would need to add to 85 to make 113. So we start this direction, we can't take 5 from 3, so we borrow, and 5 from 13 is 8. Again here we can't take 8 from 0, so we borrow from there to give an answer of 28. Question 2, symmetry. And what we do here is we work with the straight lines, and every point at the end of a straight line, whatever distance, vertical distance that is away from the mirror, 1, 2, 3, 4, 5, is reflected the other side. So from there, with a 5, 1, 2, 3, 4, 5 will take us to there. So draw that in. Then we get the curve. We leave the curve until the end, so we'll come down here. That line is 2 squares, so that's going to take us 2 squares in that direction. And then this point here is 3 squares away, so it will be 3 squares away that way. And then to complete the curve, you can see that it's curving in towards the mirror, so it needs to curve in towards the mirror this way as well. So that's the curve that you're looking for, and you can see there that if you were to fold the page along that line, then one side is identical to the other. Draw and name a quadrilateral which is exactly 2 lines of symmetry. You'd be tempted to draw a square here as a quadrilateral, but with a square you have got not only a vertical and a horizontal, but you've also got diagonals. So it's not a square. Probably the best one to go for would be a rectangle. So with a rectangle, you've got one line of symmetry going in that direction. If that was to fold over, that would be a line of symmetry, and similarly in this direction you've also got line of symmetry. If you fold that way, it'll fold there. So that quadrilateral is called a rectangle. And a triangle with exactly one line of symmetry would be an isosceles triangle. Okay, we mark an isosceles triangle by putting lines on the 2 equal sides. This will be the line of symmetry, and the name of that triangle is an isosceles. Question 3. Write down the smallest 4-digit number that can be made using all the numbers 7, 5, 8 and 2. So to make it as small as possible, it's going to be a number in the thousands because you're going to have 4 digits in it. So you're going to want the biggest numbers in the smallest place value. If you've got units, tens, hundreds and thousands, if you put the big digits up here, they're going to be worth a lot of value because they're going to be worth thousands. So because I want the smallest, I'm going to want the smallest numbers up here and the biggest numbers down here. It's a 4-digit number, doesn't matter if it's odd or even, so we would write that as 2, 5, 7, 8. 2,578. And then for part 2, write down the largest odd 4-digit number that can be made using all the numbers. Well, it's the largest, so you're going to want your biggest numbers in the thousands placeholder, but we also need to have one of the odd digits in the units place number in order to make it odd. So it's going to start with 7. No, it's not, sorry. It's going to start with 8, and it's going to have a 5 in the units column. So it's going to start with 8, then it's going to be 7, then 2, then 5. We need that 5 there in order to make it an odd number. So 8725 would be the largest odd 4-digit number you can make. Write 4,736 correct to the nearest 10. Well, the nearest 10 is where the 3 is. So correct to the nearest 10, you're either going to have 4,730, or 4,740, 40. It is nearest, 36 makes it nearest to 40. So to the nearest 10, that's going to be 4,740. Correct to the nearest 100, the 7 is in the hundreds column, so it's either going to be 4,700 or 4,800. Because the rest of the number is 36, it's closer to 4,700. How many tickets at £4.94 each can be bought with 2 £20 notes? Now you need to read this question carefully and spot there that what we're talking about is £40. Okay, so what we do is £4.94 we call a fiver, and we see how many times 5 goes into 40, and it goes in 8 times. So that's the number of tickets that we can buy. Right, question 4. In most of the past paper questions that we've done, most of the past papers that we've done, sorry, there's always a question on metric units that you would write down the units for volumes and so on. This one's slightly different in that they're giving you not only the units but some numbers to play with as well. The volume of a kettle, well, that's 1 litre. Okay, the standard to think of with capacity is a can of pop. A can of pop is usually 500 millilitres or 300 millilitres. So 100 millilitres is going to be way too small for a can of kettle. 10 centimetres cubed is too small as well, and 1 centilitre is the same as 100 millilitres. So the only one there that's sensible is a litre. The weight of a woman, similarly, a middle weight, something that's got a middleish sort of weight would be in kilograms. Grams is too light, milligrams is even lighter, and 600 kilograms would be more than half a ton. So the only sensible weight there for a woman is 60 kilograms. The distance from London to Paris is going to be measured in kilometers. You've got to have a reasonable idea of the distance. 3,400 is much too big. 34 and 3.4 are way too small. The only reasonable possibility there is 340 kilometers. For the area of the page, I mean, you can work this out roughly. That's 21, so if we call it 20 centimeters that way, and in this direction, although I've zoomed in you can't see it, it's about 30. So we've got 30 times 20, which is 600, and the units are centimeters squared. Okay, for area. So you need to be careful because there are two 600s there. That one, which is correct, and that one, which has got cm3 after it, which is volume. So the only correct answer there is 600 square centimeters. And that gets us into the grading now. Question 5. In a raffle, 20 yellow tickets numbered from 1 to 20 and 30 green tickets numbered from 1 to 30 are sold. All 50 tickets are put in a drum and 1 ticket is chosen at random. What is the probability that the yellow ticket with the number 7 on it is selected? Well, in the drum there are 50 tickets, so our probability is going to be measured out of 50. And of those 50 tickets, there is only 1 ticket which is the yellow number 7. So that would be 1 out of 50. B. Harry says that the probability of choosing a ticket with the number 16 on it is more than the probability of choosing a ticket with the number 26 on it. Explain, giving full details, whether or not Harry is correct. Well, if we're just talking about the number 16, there are in fact 2 number 16s in the drum, because there's 1 yellow 16 and there's also 1 green 16, whereas the number 26 there's only 1 of, because there's no yellow ticket number 26. So Harry is correct. So Harry's correct because there are 2 tickets with 16 on. So the probability will be 2 out of 50. But only 1 ticket with 26 on. So that would be a probability of 1 in 50. So Harry is correct. There is a greater probability of getting the number 16 than the number 26. Number 6. The chart shows the number of boys and girls in each year in a school. Each full square represents 12 pupils. So you can see here that in year 7, the number of boys are going from 0 in this direction, 1, 2, 3, 4 squares. Each square is worth 12, so that would be 4 12s, 48 boys in year 7. So how many boys are there in year 7? 48. 12, 12, and 12, and 12. How many more girls are there in, how many more girls than boys are there in year 9? Well, if we look at the number of boys, we got 1, 2, 3, 4, 5 and a half, so that will be 12, 12, 12, 12, 12, 6. 1, 2, 3, 4, 5 12s are 60, 66, and 1, 2, 3, 4, 5, 6. 6 12s are 72. So there are 72 girls, there are 66 boys, so there are going to be 6 more. Estimate the total number of pupils in year 10. Well, in year 10 I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 full squares. There's 144, plus if you chop that little bit off there and put it there, we've almost got another group of 12. I'm going to call it 10 because that's not quite going to make up a full square there. So it's going to be 144 and 10 is 154 pupils. Have the number of pupils joining the school risen or fallen over the last 5 years? Explain your answer. Well, the students coming in every year, you can see in year 11, 5 years ago, those would have been in year 7, and there's a lot more of them. And then in year 10, there are fewer, and year 9, there are fewer, and so on. So what that graph is showing you is that the number of pupils joining the school has fallen over the last 5 years. So if we say when year 11 were in year 7 5 years ago, okay, it has fallen. When year 11 were in year 7 5 years ago, there were more of them. The numbers have got smaller every year since. Okay, you can see that total bars in every year are smaller than the one above. Number 7, write down the next term. So we haven't got to work out the rule, we've just got to work out what's happening. So this is going up in 6, add 6, add 6, add 6, 21, add 6, 27. This one is going down in 7s. 85 take 7 is 78, take 7 is 71, take 7 is 64, take 7 is 57. Miranda thinks of a number. She adds 5 to her number and then divides the answer by 6. This gives her answer of 8. So once you've formed your number chain like that, what you do then to work out what the question mark is to work backwards through it, and when you go backwards through a number line, you do the opposite. So first of all, you do 8 times 6. 8 times 6 is 48, and then from that we've got to subtract 5 to give us the answer. So we do 8 times 6 is 48, 48 take away 5 is 43. And you can check that by going the other way. 43 add 5 is 48, divided by 6 is 8. C, simplify. All letters are the same, so it's going to be 5h add 6h, which comes to 11h, and then we're going to take 4 h's off that, which is going to give us 7h. Find the value of 5a, add 3b, when a is 6 and b is 4. The key thing to remember here is that the 5 and the a are joined by a multiply, as are the 3 and the b. So when I substitute the a in, it becomes 5 times 6, and it's 3 times 4. And you have to work out the multiplies before adding. So you do 5 6s are 30, plus 3 4s are 12, equals 42. E. There is a connection between x and y coordinates in the following points. So what are we doing to go from 1 to 4? And the same thing has to work with the others as well. So if we're adding 3, 1 add 3 is 4, 2 add 3 is 5, it's not 8, so that's not what's happening. Times it by 4, 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, and so on. So we can see that what's happening, the rule is a times 4 rule. So this is going to be 10 times 4 is 40, and this is going to be a times 4, which we write in algebra as 4a. So the first thing you do is look at what you're given to work out what's happening, what the rule is, and then apply the rule to the other numbers that you're given. Question 8. The diagram shows a number of cubes of side 1 centimeter forming a solid shape. Find by counting the cubes the volume of the shape and state the units of your answer. Well, it's volume, and each of the cubes is 1 cm3, 1 centimeter cubed. So what we've got here is 1, 2, 3 in the first step, and then in the second step we're going to have 3 beneath that and 3 above it, which is 6, and then in the final step we're going to have 3 plus 3 plus 3 plus 3, which is 12 cubes. So in total, my total volume is going to be 3 add 6 add 12, which is 21, and the units are cubic centimeters. Okay, so when you're doing that, what you have to remember is that each subsequent step has got 3 cubes beneath what you can see. Measure the size of angle A, B, C to go from A to B to C. The middle letter tells you which angle. It's this angle that we need to measure. So we get our angle measurer, protractor. The center of the protractor needs to go on the corner where the angle is that we're measuring, and then the 0 needs to line up with one of the sides. So there's the 0, so I'm going to line that up like that, which is reflecting badly. There we go, do it there. And then what we do is we measure, and we can see that in this, going in this direction, the 10, 20, 30s count up the inside scale. So we go up, we can see it's just over 60, but it's less than 70, and we read off here, so we got 60, 61, 62, 63. I make that 64 degrees. Part 2, we've got to draw an angle this time. Draw the line PQ so that P to Q to R is 136. So Q is the middle, so that's going to be the center of my angle. So same again, take the center of the protractor, put it on Q, line the 0 up with the line that we've given, and we now need to go to 136. Now a little sketch to make sure that we're going to end up reading the right thing. 136 is bigger than 90, it's less than 180, so that's the kind of angle we should be expecting once we've drawn it. So again, it's the inside scale that we're measuring in this direction, so we're going to go around. 130 is there, 140 is there, 136 is going to be there. Mark the dot, draw the line. Doesn't say how long it needs to be. Put a P up there, PQR. That looks like the sketch that I've done up there, so I'm quite happy that that's going to be right. And the name of that type of angle between 90 and 180 is obtuse. And that's an angle fact you need to know. Question 9. Simon has made 237 jugs to sell. He packs them in crates that hold 32 jugs each. How many full crates will he have and how many jugs will be left over? So we need to see how many 32s there are in 237. Now you could do that by division or you could do it by trial and error. It doesn't really matter. It's going to be less than 10 because 10 jugs would be 320. So it's going to be less than 10, so less than 10 as 10 lots of 32 is 320. I'm going to go with 7. So I'm going to do 32 times 7. 2 7s are 14, 4 down carry 1, 3 7s are 21, that's 224. So 7 crates will be 224. So 8 crates would be 32 more than that, which is going to go bust. So that's my first guess is right. 7 crates, and then left over would be 224. 234 would be 10. Add another 3 would be 13. So it would be 7 crates with 13 left over. Okay, so just go through that again. As far as you need to see how many 32s fit into 237. The best way to do it is to take a guess first of all and work from there. So I knew they were going to be less than 10 because 10 lots of 32 would be 320. You just add a 0. So it's fewer than 10. It's going to be more than 5 because half of that is 160. So I tried 7. 32 lots of 7 was 224, which was the right choice to make because that just leaves 13 left over that won't fit. B. Calculate 3/8 of 56. First of all, with any of these, find 1/8. 1/8 will be 56 divided by 8, which is 7. So 1/8 is 7, so 3/8 will be 3 lots of 7, which is 21. Find 7% of 500. First of all, find 1% of 500 by dividing by 100, which will be 5. So 7% will be 5 lots of 7, or 7 lots of 5, which is 35. So find 1% by dividing 500 by 100, giving you 5. So if 1% is 5, 7 is going to be 7 lots of 5, which is 35. Okay, then we're on to a distance time graph. Won't quite fit on the screen, so I'll move it up when I need to. Chris goes for a drive in his car. He stops twice during his journey. The graph shows his journey. How far did Chris travel between 9 o'clock and 10 o'clock? So again, as I've said with all the other graph work that we've done, the first thing to do is work out what each little square is in each direction or on each axis of your graph. It makes everything else easier to deal with. So you can see here we're going from 0 to 10 in 10 jumps. So in that direction, each little square is 1 mile. That looks like half a mile, isn't it? 1 mile in that direction. And then in the time direction, we're going from 9 to 10, which is 60 minutes in 10 jumps. So 60 divided by 10 is 6. So every little square in this direction is 6 minutes. So back to the original question, which was how far did Chris travel between 9 o'clock and 10 o'clock? So there's 9 o'clock, there's 10 o'clock. He started at 9 o'clock, 10 miles from Chris's home, and an hour later he was at 40 miles. So that distance isn't 40, he's actually travelled 30 because he's gone from there. So it's 10, 20, 30 miles. B. For how many minutes altogether did Chris stop on his journey? Well, you can tell where the stoppage is. It's when time is moving but distance isn't. So if you take a look there, time is carrying on but there's no change in distance. So he stopped from there to there, which is 30 minutes halfway, and then another 12, so that's going to be 42 minutes from there to there, and then another 30 minutes there. So in total he stopped for 42 plus 30 equals 72 minutes. Without calculating any speeds, explain how you can decide whether Chris was driving faster before or after stopping for the first time. Well, the faster you travel, it means the more distance you cover in a smaller amount of time, and that on a graph makes the line steeper. So the steeper the line, the faster he's traveling. So you can see there that the line is steeper before the stop than it was after the stop. So we can say Chris was driving faster before his first stop. Chris was driving faster before his first stop because the line on the graph is steeper there. Okay, it's a steeper line, so he's traveling faster there than he was there. At what time did he arrive home? Well, he gets home here, which is 2 squares before 4 o'clock, 1600. So that's 12 minutes before 1600, which is going to be 15:48. If you add 12 to that, you get 60. There's 60 minutes in an hour. Okay, so those are the first 10 questions on this November paper 1.